Precast concrete is a construction product produced by casting concrete in a reusable mold or form, which is then cured in a controlled environment, transported to the construction site and lifted into place. In contrast, standard concrete is poured into site-specific forms and cured on site. Precast stone is distinguished from precast concrete by using a fine aggregate in the mixture, so the final product approaches the appearance of naturally occurring rock or stone. By producing precast concrete in a controlled environment, the precast concrete is afforded the opportunity to properly cure and be closely monitored by plant employees. Utilizing a precast concrete system offers many potential advantages over site casting of concrete. The production process for precast concrete is performed on ground level, which helps with safety throughout a project. There is a greater control of the quality of materials and workmanship in a precast plant rather than on a construction site. Financially, the forms used in a precast plant may be reused hundreds to thousands of times before they have to be replaced, which allow cost of formwork per unit to be lower than for site cast production. Many states across the United States require a precast plant to be certified by either the Architectural Precast Association, National Precast Concrete Association or Precast Pre-Stressed Concrete Institute for a precast producer to supply their product to a construction site sponsored by state and federal DOTs. There are many different types of precast concrete forming systems for architectural applications, differing in size, function, and cost. Precast architectural panels are also used to clad all or part of a building facade, freestanding walls used for landscaping, soundproofing, and security walls, and some can be pre-stressed concrete structural elements. Stormwater drainage, water and sewage pipes, and tunnels make use of precast concrete units. The New South Wales Government Railways made extensive use of precast concrete construction for its stations and similar buildings. Between 1917 and 1932, they erected 145 such buildings. Brief history: ancient Roman builders made use of concrete and soon poured the material into molds to build their complex network of aqueducts, culverts, and tunnels. Modern uses for precast technology include a variety of architectural and structural applications featuring parts of or an entire building system. In the modern world, precast panelled buildings were pioneered in Liverpool, England, in 1905. A process was invented by city engineer John Alexander Brodie, whose inventive genius also had him inventing the football goal net. The tram stables at Walton in Liverpool followed in 1906. The idea was not taken up extensively in Britain. However, it was adopted all over the world, particularly in Eastern Europe and Scandinavia. In the US, precast concrete has evolved as two sub-industries, each represented by a major association. The precast concrete products industry focuses on utility, underground, and other non-pre-stress products, and is represented primarily by the National Precast Concrete Association. The precast concrete structures industry focuses on pre-stressed concrete elements and on other precast concrete elements used in above-ground structures such as buildings, parking structures, and bridges. This industry is represented primarily by the Precast Pre-Stressed Concrete Institute. Precast concrete products: the following is a sampling of the numerous products that utilize precast pre-stressed concrete. While this is not a complete list, the majority of precast pre-stress products can fall under one or more of the following categories: agricultural products. Precast concrete products can withstand the most extreme weather conditions and will hold up for many decades of constant usage. Products include bunker silos, cattle feed bunks, cattle grid, agricultural fencing, H-bunks, J-bunks, livestock slats, livestock watering trough, feed troughs, concrete panels, slurry channels, and more. Pre-stressed concrete panels are widely used in the UK for a variety of applications including agricultural buildings, grain stores, silage clamps, slurry stores, livestock walling, and general retaining walls. Panels can either be used horizontally and placed either inside the webbings of RSJs or in front of them. Alternatively, panels can be cast into a concrete foundation and used as a cantilever retaining wall. Building and side amenities. Precast concrete building components and side amenities are used architecturally as fireplace mantels, cladding, trim products, accessories, and curtain walls. Structural applications of precast concrete include foundations, beams, floors, walls, and other structural components. It is essential that each structural component be designed and tested to withstand both the tensile and compressive loads that the member will be subjected to over its lifespan. Multi-story car parks are commonly constructed using precast concrete. The constructions involve putting together precast parking parts which are multi-story structural wall panels, interior and exterior columns, structural floors, girders, wall panels, stairs and slabs. These parts can be large, such as double T structural floor modules, which are lifted in place at the sites by precast concrete lifting anchor systems. Retaining walls. Precast concrete provides the manufacturers with the ability to produce a wide range of engineered earth retaining systems. Products include commercial retaining wall, residential retaining walls, sea-walls, mechanically stabilized earth panels, modular block systems, segmental retaining walls, etc. Retaining walls have 5 different types, which include gravity retaining wall, semi-gravity retaining wall, cantilever retaining wall, counterfort retaining wall, and buttress retaining wall. Sanitary and stormwater. Sanitary and stormwater management products are structures designed for underground installation that have been specifically engineered for the treatment and removal of pollutants from sanitary and stormwater runoff. These precast concrete products include stormwater detention vaults, catch basins, and manholes. Utility structures. For communications, electrical, gas or steam systems, precast concrete utility structures protect the vital connections and controls for utility distribution. Precast concrete is non-toxic and environmentally safe. Products include hand holes, hollow core products, light pole bases, meter boxes, panel vaults, pull boxes, telecommunication structures, transformer pads, transformer vaults, trenches, utility buildings, utility vaults, utility poles, controlled environment vaults and other utility structures. Water and wastewater products. Precast water and wastewater products hold or contain water, oil or other liquids for the purpose of further processing into non-contaminating liquids and soil products. Products include aeration systems, distribution boxes, dosing tanks, dry wells, grease interceptors, leaching pits, sand oil water interceptors, septic tanks, water sewage storage tanks, wet wells, fire systems and other water and wastewater products. Transportation and traffic-related products. Precast concrete transportation products are used in the construction, safety and site protection of road, airport and railroad transportation systems. Products include box culverts, 3-sided culverts, bridge systems, railroad crossings, railroad ties, sound walls barriers, jersey barriers, tunnel segments, precast concrete barriers, TVCBs, central reservation barriers and other transportation products. These are used to make underpasses, surface passes and pedestrian subways, so that traffic in cities is disturbed for less amount of time and for other purposes. Precast concrete is also used for the rollways of some rubber-tired metros. Modular paving. Modular paving is available in a rainbow of colors, shapes, sizes and textures. These versatile precast concrete pieces can be designed to mimic brick, stone or wood. Specialized products. Cemetery products, underground vaults or mausoleums, calls for quality watertight structures that withstand the tests of time and the forces of nature. Hazardous materials containment. Storage of hazardous material, whether short-term or long-term, is an increasingly important environmental issue, calling for containers that not only seal in the materials, but are strong enough to stand up to natural disasters or terrorist attacks. Marine products, floating docks, underwater infrastructure, decking, railings and a host of amenities are among the uses of precast along the waterfront. When designed with heavyweight in mind, precast products counteract the buoyant forces of water significantly better than most materials. Precast concrete structures. Pre-stressed concrete. Pre-stressing is a technique of introducing stresses into a structural member during fabrication and/or construction to improve its strength and performance. This technique is often employed in concrete beams, columns, spandrels, single and double Ts, wall panels, segmental bridge units, bulb T-girders, I-beam girders, and others. Pre-stressed member are crack-free under working loads and, as a result, look better and more watertight, providing better corrosion protection for the steel. Many projects find that pre-stressed concrete provides the lowest overall cost, considering production and lifetime maintenance. Precast concrete sandwich wall panels. Origin. The precast concrete double wall panel has been in use in Europe for decades. The original double wall design consisted of two withes of reinforced concrete separated by an interior void, held together with embedded steel trusses. With recent concerns about energy use, it is recognized that using steel trusses creates a thermal bridge that degrades thermal performance. Also, since steel does not have the same thermal expansion coefficient as concrete, as the wall heats and cools, any steel that is not embedded in the concrete can create thermal stresses that cause cracking and spalling. Development. To achieve better thermal performance, insulation was added in the void, and in many applications today the steel trusses have been replaced by composite connection systems. These systems, which are specially developed for this purpose, also eliminate the differential thermal expansion problem. The best thermal performance is achieved when the insulation is continuous throughout the wall section, that is, the withes are thermally separated completely to the ends of the panel. Using continuous insulation and modern composite connection systems, R values exceeding R22 can be achieved. Characteristics. The overall thickness of sandwich wall panels in commercial applications is typically 8 inches, but their designs are often customized to the application. In a typical 8-inch wall panel, the concrete withes are each 2-3/8 inches thick, sandwiching 3-1/4 inches of high R-value insulating foam. The interior and exterior withes of concrete are held together with some form of connecting system that is able to provide the needed structural integrity. Sandwich wall panels can be fabricated to length and width desired, within practical limits dictated by the fabrication system, the stresses of lifting and handling, and shipping constraints. Panels of 9-foot clear height are common, but heights up to 12 feet can be found. The fabrication process for precast concrete sandwich wall panels allows them to be produced with finished surfaces on both sides. Such finishes can be very smooth, with the surfaces painted, stained, or left natural. For interior surfaces, the finish is comparable to drywall in smoothness and can be finished using the same prime and paint procedure as is common for conventional drywall construction. If desired, the concrete can be given an architectural finish, where the concrete itself is colored and/or textured. Colors and textures can provide the appearance of brick, stone, wood, or other patterns through the use of reusable form liners, or, in the most sophisticated applications, actual brick, stone, glass, or other materials can be cast in the concrete surface. Window and door openings are cast into the walls at the manufacturing plant as part of the fabrication process. In many applications, electrical and telecommunications conduit and boxes are cast directly into the panels in the specified locations. In some applications, utilities, plumbing, and even heating components have been cast into the panels to reduce on-site construction time. The carpenters, electricians, and plumbers do need to make some slight adjustments when first becoming familiar with some of the unique aspects of the wall panels. However, they still perform most of their job duties in the manner to which they are accustomed. Applications and benefits. Precast concrete sandwich wall panels have been used on virtually every type of building, including schools, office buildings, apartment buildings, townhouses, condominiums, hotels, motels, dormitories, and single-family homes. Although typically considered part of a building's enclosure or envelope, they can be designed to additionally serve as part of the building's structural system, eliminating the need for beams and columns on the building perimeter. Besides their energy efficiency and aesthetic versatility, They also provide excellent noise attenuation, outstanding durability, and rapid construction. See also. References. Prefabricated systems for building and civil engineering works. http personal.scitu.edu. Photolib prefabricated PDF. External links. APA Architectural Precast Association, Canadian Precast Pre-Stressed Concrete Institute, British Precast Concrete Federation, BIBM, European Federation for Precast Concrete, Midwest Precast Association, National Precast Concrete Association Australia, National Precast Concrete Association, Precast Pre-Stressed Concrete Institute. A Comfortable House for $1,000, Popular Science Monthly, February 1919, page 39, scanned by Google Books. 1, FIB Bulletin 43 Structural Connections for Precast Concrete Buildings.